Alright, we have now established saving and loading functionality so that we can save out and reload node networks. Now, in order to make this operation more user-friendly, we are going to include the use of open and save file dialogs. This way, when the user hits Ctrl-S or Ctrl-O, they'll be presented with a familiar dialog that will let them select the file to save or open. So to get everything started here, what we're going to do is we will add a couple of new methods to Node.io that will let us invoke the dialogs themselves. And then after invocation, then depending on the result of the dialog, if the user actually selected a file, then we'll also need to code in the necessary code to make sure that our saves and loads get fired off. So we need to begin with the dialog itself. We need to gain access to first the open file dialog and the save file dialog that are part of the system.windows namespace. Now, in order to bring the type in, we'll focus on the using directive itself, but in addition to this, we will need to also bring in the reference that holds the types we're looking for. So the using is going to be using system. Actually, let me correct the casing on system. So we have system.windows.forms. Now, of course, if we were to try and build at this point, we get an error on the fact that the namespace Windows does not exist, which makes sense because we have not yet referenced an assembly that defines this namespace. So in order to do that, we're going to go up to References. We will right-click and add a reference. We'll give the References dialog just a moment to load up. Then under the .NET tab, we will scroll down until we see system.windows.forms. So if we scroll up just a little bit here, we have system.windows.forms. We'll hit OK on this reference, so that will reference the system Windows Forms assembly. With this reference in place, you can see that clears up the error on our namespace that we're opening with the using directive. So with this in place, we now have access to, among other things, the open and save file dialogs. So here inside of Node.io, let's actually begin with the save dialog. We'll make a static method, and before we define these methods, in order to work with the dialogs themselves, we're going to need to hold references to actual open and save file dialog objects, since they are implemented as individual objects themselves. So we will begin with two static fields. The first field is going to be a static field of type open file dialog. We're going to call this field dialog open. And we can turn around and create the object with a field initializer. So we will say new open file dialog, and that will take care of the dialog itself. Now we need to do the same thing for a save dialog, so we will drop in a static save file dialog called dialog save, and this will be set to a new instance of save file dialog. Alright, with both of these fields in place and instantiated, the dialogs themselves are ready for use, ready to be shown, and return a file name if the user should so choose. Now let's begin with the method that will invoke the save dialog. We'll make a public static method with a void return type called show save dialog. And let me grab a capital D on dialog in the name. We don't need to pass in any parameters, so we'll simply jump down and drop in our method body. Now what we need to do here is we need to actually show the dialog itself, and we'll notice that the show method of the dialog is actually modal, as in it holds up execution, and that means we can wait for the result of that method to see what the user actually did. So that means we're actually going to invoke the dialog from inside of an if statement. So we'll say if dialog save dot show dialog. Now show dialog is a method, so we'll drop in our parentheses. Now show dialog is going to return a dialog result. So we can say if that result is equal to dialog result dot OK, then the user decided to go ahead and save the file. That means that we are ready to call the save nodes method. We need a file name to hand over to save nodes, but again, since the user had just selected a file, that file will be available inside of the dialog save object itself. So that means we're ready to invoke the save nodes method. Then we'll pass in the file name of dialog save dot file name. Now for saving, that's all we need to do. That will end up firing off that file name gathered from the dialog off to save nodes, and we should get the resulting file saved out. Now we can address our loading method. Now, most of this method is the same as our saving. Actually, let me drop this in right below so we order the save and load the same that we had ordered our save and load for our nodes. Now, for the method signature and definition itself, we'll have much the same thing, where we define a public static method with a void return type, this time calling the method showLoadDialog. Then we can drop in the method body. Now we need to do the same thing in order to actually invoke the dialog. We'll begin an if statement so we can see the result of that dialog. So we'll say if dialog open dot show dialog open closing parenthesis is equal to dialog result dot OK, then the user decided that they want to select and open a file. So this time we'll brace in our if statement with some curly braces so we can add a few different things that we're going to do. In addition to simply loading, we're also going to need to make sure that we clear out all of the existing nodes. Up until now, as we've been testing the save and load functionality, we've been testing it on a clean run of the application. We haven't yet run into a scenario where the user has been able to load the nodes twice. So for example, if you had loaded the simple triangle graph and then loaded the entire grid graph, if you don't clear out the nodes, you'll end up in a scenario where you continue to apply more and more nodes instead of clearing out the scene. Now the expected result that a user would be looking for when they load in a node graph is to simply have the new graph completely replace the old one. That means we need to erase all of the old nodes before we load new ones in. Now in order to do this, since we're actually going to need to loop through and remove nodes while we're looping, we're going to need to construct a special for loop that will let us remove nodes in a way that doesn't disrupt the loop itself. To do this, we're going to create a reversed for loop. So I'll begin with the for_rr template, then hit tab to drop in the template code. Now we will loop using the I index variable, and we'll be looping over all of our actors. So we will take actor.actors.count as our starting value, and we will start at the very end of this list and loop back towards the beginning. The reason that we're looping over all of our actors is because actors can easily be addressed by number with a number that isn't specific and isn't disrupted by the actors being deleted. The reason we're doing this rather than pulling out an iterator or an enumerable over individual nodes like we had been doing earlier with of type is the fact that disrupting the collection will end up disrupting the IEnumerable iterator itself. So again, we need to do this at the actor level just so that we can gain access to things as we delete them. So what we'll do is, as we're going through our actors, the only things we really want to clear out are nodes. So we'll do a check and make sure that the current actor, which we can reference with actor.actors sub I, if that actor is a node, so we can say if that actor is node, then we can go forward with the deletion of that actor. So that means we can take actor.actors sub I dot delete. And here the code is kept simple since delete is actually implemented more specifically in the node itself, so we just rely on the node itself cleaning up anything it would need to. But then the end result is that the node gets pulled out of the actors list, which doesn't affect us here since we're removing only a single actor from an index that's about to go away anyway, since once we finish with this deletion, the next thing we do is we actually decrement I and move back to a node that we can address since we're deleting backwards. So even if we delete all of the nodes, we delete the node once we're done with it. So once this loop runs, this will clear out all of the nodes in our scene, and we will have a fresh scene that we can load new nodes into. So we will perform the actual loading of nodes using the load nodes method. We need to pass in a file name, so we will get the file name from our dialog open object looking at the file name field. Alright, with all of this in place now, we are ready to test things out, but we may have to handle a specific case with the use of the dialog itself. But for an initial test, let's simply load things up. Here we have this blank scene We'll hit Shift a few times to click out some nodes. Now let's hit Control S. Now actually, I'll pause just here for a minute because we've not yet changed the code to invoke the dialogues. If we hit Control S now, we're of course just going to be overwriting that node's text file. So really what we want to do is over here in Scene Editor, we want to adjust our code down here inside of our input. Rather than directly addressing save nodes, we would instead like to address the show save dialog method. Then when loading, we'll do the same thing with our loading and address the show load dialog. Alright, with both of these adjustments in place, let's bring up our code or our game once again, hit Shift and click out some nodes, then hit Control S to bring up the save dialog. Now we'll give it a minute, and instead of showing the dialog, we instead get an exception when we attempt to use the dialog, showing that we need to have a specific threading compartment enabled for use on the OLE calls. And this goes back to the fact that these dialogs are in fact integrated with the COM subsystem. And what it's noting here is the fact that if we want to have our application running in the proper threading compartment, we have to mark it with this STA thread attribute over the main function itself. So since we have nothing in our code that is going to be affected by using STA thread, we're simply going to jump down here in our project to the program code file for the game itself. If we load that up, we can see that all the main method is doing is simply instantiating and beginning the game itself. Now this is, as noted by the summary, the actual entry point for the application, so this is where we need to mark STA thread attribute. So we'll mark this attribute using an opening square brace, and we'll say STA thread attribute, or rather just STA thread, and that makes the attribute itself. So with this in place, let's now run, click out a few nodes, hit Control S, and here we go. We get an actual save dialog. Everything in our code is now happy. We've set up the proper threading compartment for use with the dialog. Now right here we can see that we've got this set to a location on the hard drive that was used for earlier testing. What I want to do is look at the location that our game resides in. So just to do that very quickly, what I'm going to do is we already had this folder open with our node's text file. I'm actually going to click on and grab the entire path to this location, go back into our game, hit Control S, grab the dialog, and paste in our path. So now we're looking at the location of the game itself. Now this was just a simple set of 3 nodes, so I'm going to call this simple.txt. We'll hit save, and that'll take care of all of these nodes. Now in order to test loading them, I'm going to first by hand delete them just so we can see a visual change. Then I'll hit Control O. We can see that the open dialog is also working. We can see the simple text file. We can hit open, and that restores all of our nodes. Now to show the fact that it's clearing the scene, I'm going to move some of these nodes around. So we can see that they've been moved to be in a straight line. Now if we hit Control O and reopen the simple node scene, the node scene gets completely restored and those nodes get erased. This prevents the possibility that we could reopen the same scene over itself multiple times. Now let's save out maybe a few more examples to show something more complex. I'm going to hold Shift and draw out a series of nodes to make a simple network. We'll actually make a simple 3x3 grid. So I'll grab some of these vertical lines and connect them up. And this final one here, then I'll take the very bottom node, hold Shift, create a new node off the bottom, and then encircle the current graph with some additional nodes, and finally close the connection. So this makes a really rough hand-drawn version of our earlier grid inside of a circle that we had created with procedural methods. But now let's say that we had actually designed this hand-drawn grid around a specific specification we needed for navigation. And now we want to be able to save this network out so we can reload it and work on it later, or even implement the loading code inside of an actual game that needs to load in the pathing information. So let's hit Control S. Let's save this out as drawn.txt, just to note the fact that this one was hand-drawn versus the earlier ones. We'll hit save. Then one last node graph I want to save out is we'll grab an actual file that represents our procedurally built grid with the missing nodes in the middle. Now in order to get that grid, we do need to go back to our code in our scene editor, reconstruct it once so that we can save it. So we'll bring our grid creation code back. We'll run the game. We'll hit Control S once we see our grid network, and we can just simply call this one grid. We'll hit save on the grid network, close the application. One final time we will go in and comment out our procedural building so that if we run the game we get a blank scene, but now we're able to hit Control O and open up the grid, and it appears that I didn't name this with the .txt. Let me very briefly go in here and just change it over to a text file. Again, we're not actually limiting by file in the dialog. Again, that's up to you depending on the type of extension you would like to actually use with your app. We had used the text extension just to make it easy to debug inside of Notepad. But here we can open up our grid. We can see that the full grid is restored. We could instead open up the hand-drawn version, get our hand-drawn version, or open up the grid again and see that the scene clears out each time that we load in our node network. So with all of this in place, we have seen that we now have the ability to serialize and save out our node network to a file. We have the ability to load the data back in from that file to reconstruct a node graph, and we have integrated an open and save file dialog to make it easier for a user to work with node scenes. So with that, that's going to wrap up this video.